All right, this is the lesson video for Algebra 2, Pro Unit 7, Lesson 1. So this lesson has a lot of material in it. So I'm going to try to kind of work out an example of each problem. I don't really like the way they just jump right into doing division like they do. So we're just going to talk through the different levels, in a sense, of doing simplifying rational expressions. So when we talk about rational expressions, what we really mean is the word there, the key word in rational, or the key part of rational, is ratio. So a rational expression is any polynomial or any polynomials that are being divided by each other. So in a sense, even a number like 2/3 could be considered a rational expression. But we're going to be looking at things more like maybe 2x over 3y, or even more complicated than that, something like this, that is also considered a rational expression. So you can see how complex a rational expression can get, but the thing that ties all these together is that they are all ratios. They are all fractions. So our goal is going to be to understand how to simplify these types of expressions. So the first type of rational expression we need to learn how to simplify is very much like the first example I showed you, which is just a fraction made up of numbers. So really the first layer of this is just something you've learned in the past, which is just simplifying fractions or reducing fractions. So what you need to remember is that when we're reducing fractions like this, and this is going to apply to all of this stuff, we are looking for how can I cancel or reduce this by the same factor. So really, I want to rewrite these as a factor of two numbers. So let's rewrite 12 as 3 times 4, and let's rewrite 15 as 3 times 5. And we see that once we do that, the 3's here cancel each other out, and that is what we're looking to do when we're reducing or simplifying that rational expression. So that would be an example like the first problem in your lesson. And then they take it up a level. They say, okay, what if you had a rational expression with variables? 3a over 3b. Well, what they want you to understand is that variables function the same way that numbers do, and they can be canceled out with each other if there are two of the same. Well, in this example, there are not two of the same. So the 3's would cancel out, canceling out completely, leaving me with 1a over 1b, which also probably the most simple way to put that would just be to put a over b. Again, that's very much like number 2 in your problem. I'm going to go and put those numbers right here. Number 1, number 2. For number 3, they take it up yet another level. Let's say I had the following: 4b to the third over 6b. So how does this work? Well, let's break this down. 4 can be 2 times 2, and b can be b times b times b. And 6 can be 2 times 3 times b. And so once we do that, you can see pretty clearly these 2's will cancel out, these b's will cancel out, leaving me with 2b squared over 3, and that would be the final answer. So that is what we're looking to do when we have these things made of single terms or factors. So we want to cancel out whatever factors we can cancel out. It even applies to factors of polynomials. So for instance, if I have the following: 8 x plus 1 x minus 3 divided by 12 x minus 3 x plus 2. So this looks really, really complicated, but really this is not much different than what we had in this step right here. So in that step, we had a bunch of factors and we canceled out any that we could. So let's do that here. 8 can be written as 2 times 4 We obviously have factor x plus 1, that's a factor, and x minus 3 is a factor. 12 can be written as 3 times 4, and of course we have the factors again. And then we look for anything that is the same, and we cancel them out. So the 4's cancel out, and actually this entire x minus 3 cancels out, leaving me with 2 times x plus 1, that's the top of that fraction, divided by 3 times x plus 2. So that's what you're doing in number 4 of your work, is simplifying these numbers and any factors, any polynomial factors that you can do there. All right, now we take it up yet another level. They give us this, a problem like this. X squared plus 9x plus 14 divided by x plus 4, x plus 7. So what they want us to do here is they need us to actually factor this top term. And when I say factor, I mean we need to figure out what two binomials will multiply to make that expression. So the bottom, nothing's going to happen down there, but I want to know what can I get to multiply to make x squared plus 9x plus 14. And if you remember this is where we're looking for x and x, and we're looking for numbers that multiply to make 14. That's going to be 1 and 14, or 2 and 7. It's clear that 2 and 7 will add up to 9. So we do plus 2 plus 7, and we factored it. I can give you some material on factoring if you need a reminder of how to do that. But in general, remember, we're looking for numbers that multiply to make 14, but add or subtract to make 9. So once I get done with that, I look again for numbers that can be canceled out. And I see here that I have x plus 7 and x plus 7, which means that my final answer is x plus 2 over x plus 4, because we've canceled everything else out. All right, so that's the kind of first kind of part. And then from here, it switches over to asking questions about synthetic division. And dividing polynomials that are like a little bit more complicated in that one, that you cannot just factor. So we're going to work through a few examples of those and talk about kind of the process and how you get from the original problem to the synthetic division method. So let's say I have the following: x to the 4th plus x to the 3rd minus 11x squared minus 5x plus 30 divided by x minus 2. So in order to write this in synthetic division, remember you have this little t-chart, and out here you're going to write the thing that makes the denominator 0. So 2 minus 2 is 0, so we put a 2 there. Across the top, we write the coefficients of the top of this fraction, the numerator. Remember, these are going to be 1s. So we're going to have 1, 1, negative 11, negative 5, and 30. When we do synthetic division, the first thing we do is we bring down this first term. And then from there, it's just a matter of multiplying 2 times whatever is in this row, and then writing the answer in the next column. So 2 times 1 is 2. 1 plus 2 is 3. So you multiply, write the answer on the next column, add that next column. Now I do it again. 2 times 3 is 6. Negative 11 plus 6, negative 5. 2 times negative 5 is negative 10. Negative 5 plus negative 10 is negative 15. 2 times negative 15 is 30. Sorry, negative 30. Made a mistake there. 2 times negative 15 is negative 30. Negative 30 and 30 cancel each other out, leaving me with 0. And then the next important thing to understand is how you write the answer. So once you get this string of coefficients, these would be the coefficients of the new answer. So we'd have 1 and then x to the 3rd, because we started with 4th, we took an x away, and so 4 goes down to 3. And then each term after that goes down by 1. 3x squared minus 5x minus 15. We did not have a remainder, so that is our final answer. So that's how synthetic division works. So in the unit, they have you do different ways of doing this. Like some of them, they give you the completed problem and ask you to write what the answer would look like. And then in others, they have you do the entire process. So let's do another example. So you have the following. 2x to the third minus 3x squared plus 4x plus 5 divided by x plus 2. So again, we're doing synthetic division. So we are gonna, I'm actually gonna grab this and drag it down a little bit. There we go. We need to write down our problem in our t-chart. So we have a t-chart. Over here we have whatever makes this 0, and it's gonna be -2 that makes that 0. -2 plus 2 is 0. Across the top we write 2, -3, 4, and 5. Now, starting the process, you bring down the 2, and then we multiply and add on the next column. So -2 times 2 is -4. That makes -7. -2 times -7 is 14. Negative times negative is positive 14. That makes 18. -2 times 18 is -36. And you can see this one's getting a little bit out of control. So this will have a remainder. This last term is the remainder. So then when we go to write the answer, we have to take that into account. So this is the way it's going to look in our answer. Again, we go down one level from 3 down to 2. So it's going to be 2x squared minus 7x plus 18. And then the remainder looks like this. Minus 31 over x plus 2, which was from the original problem. And that's what it looks like when your answer has a remainder, which means it has some answer in the final column. All right, so there's one other type we need to look at, and that is when the divisor is a little bit more complicated than the ones we've been looking at. So let's jump over here and let's do this problem. 4x to the third minus 8x squared plus 7x minus 11 divided by 2x plus 1. Draw our t-chart. 4, -8, 7, -11. And then to figure out what goes in the box, we need to figure out what makes 2x plus 1 equals 0. So it's not as easy as the previous ones. The other ones were easy because it's like x plus 2. It's easy to see -2 is going to make that 0. So the question is, what makes 2x plus 1 equals 0? So if I just solve that little equation really quickly. Sorry. Up. Divided by 2, x equals -1/2. So it might look a little intimidating at first, but we're still going to use that as our number. And I think it's going to work out fine. So when we do this, again, I'm going to bring down 4. -1/2 times 4 is -2. That makes -10. -1/2 times -10 is +5. That makes 12. -1/2 times 12 makes -6, which makes -17. So it actually worked out even though it was a fraction. And then we go to write our answer. We write our answer, take it down one level. It was at 3. So it goes to 4x squared minus 10x plus 12 minus 17 over the original divisor, 2x plus 1. All right, so that's how those work. So pretty much this stuff about synthetic division is going to carry you from question 6, 7, 8, 9, 10, all the way through number 10. Do not do long division. you need to use synthetic division every time. Long division is just too much writing, too much place for error, and I really want you to understand how to do synthetic division. So we're going to do synthetic division for all of them. So numbers 6 through 10. And then I'm going to jump over here and I'm going to work through the review questions for you guys. So let me hop out of here and we'll scroll down. And so that gets us through 10. Starting at number 11, we have these review questions. Identify the linear inequality in standard form. What you have to do on this one is just pick the one that is in standard form. And I'll just remind you, standard form looks like this. AX plus BY equals C. And this equal sign could also be any of our inequality symbols. So just so you're aware, it doesn't matter. It's just the standard form. The point of this is that it's AX, B, Y, C. So you have X and Y on the same side of the equation with the C on its own. So you just need to pick the equation that matches that basic pattern. And so it looks like that should be pretty easy for you to get. Identify the center of the hyperbola. The center of a hyperbola is located here and here. And I'll just tell you right now, whatever makes this 0 is the x. Sorry, that's what I meant, not x. Is the h. The h is the first value. And whatever makes this 0 is the k. So you need to find what minus 1 makes 0 and what plus 3 makes 0. Those two numbers together form the center of the hyperbola, and you pick the answer choice that corresponds with those numbers. Add the polynomials. I think you should be fine on this. This comes from our last unit, but you're basically combining like terms. So you need to find the terms that can be combined. You can drop these parentheses since it's plus. And then you need to combine like terms. X squared, 3x squared can't be combined with anything, but this can be combined with this, and this can be combined with this, and I'll let you finish that out to the end yourself. All right, so those are the review questions, and that covers lesson 1.